Hey, I'm Dr. T and welcome to my office. Today I'd like to talk about the SI system, or System International, which I do realize saying SI system means you're saying system twice, which is kind of weird, but moving on. This is the replacement to the metric system. So the metric system dates to the end of the 18th century, and well, it worked well, but things needed to be improved. So via international treaty and international organizations, it has been updated. The newest form, the SI system, was established in 1964 and most recently updated in the summer of 2019. The update was, shall we say, a bit controversial, especially for the chemists, but understandable and needed. Okay, so what's the difference? Well, not a lot, truthfully. The core difference between the systems ends up being how the base units are defined. So both the metric system and the SI system have a series of base units. I'll try and put a picture there. These base units are ones that measure certain properties. Now, you're thinking, there's more than 7 properties. How can 7 units measure all of them? Well, other properties can be measured by a combination of these base units. So if I want to measure, say, volume, I don't actually measure in a unit of volume. I measure in a unit of length that has been cubed. So imagine a box 1 meter by 1 meter by 1 meter. That's a cubic meter. And thereby, I now have a unit of volume without actually creating a new defined unit. See, when each unit's defined, you're originally in the metric system based off of a physical artifact, and thus now we don't need an artifact for volume and length. We just need one for length. And in the SI system, they're based off of a physical constant. Well, the speed of light can work both for length and volume if we simply take volume as a cube of a length unit. Yay! Okay, so that actually leads us to the major difference between the metric system and the SI system, and that is how these base units are defined. The metric system, the base units were defined by an artifact, whereas the SI system, the base units are defined by some form of natural constant, whether it be something like the speed of light for the meter or the frequency in which cesium atoms respond into an atomic clock for time. Now, with both of these systems, there is still the same major innovation over previous systems. In really any unit system that you have, you run into a quick problem. If you're measuring the same property but on things of very different sizes, you run into a bit of an issue. So imagine I wish to weigh a mouse and an elephant. The same unit's going to be a little bit awkward. So I could weigh a mouse in ounces, but if I weighed an elephant in ounces, there would be a lot of ounces. I would like to go like pounds or maybe tons for the elephant. But now if I need to compare them, now I need to convert ounces to pounds or tons, and that math is a little bit awkward. Not impossible, but a little bit awkward. So the metric system comes up with this idea. It's like, okay, we've got the base unit, whether or not it be one of these fundamental base units or it be a unit derived from them. For instance, the liter, which is derived from the meter by taking a decimeter or a tenth of a meter and making a cube out of it. Either way, I can take the meter, I can take a liter, any unit I want, and I can stick a prefix in front of it, and that will change it by a factor of 10. So now I could measure a mouse in, say, grams, and an elephant in kilograms, and that would work well. I've changed the size of my unit by a factor of 1,000 by adding the K in front of it, making it a kilogram. Additionally, I can go the other direction with different prefixes, say adding a micro to my gram, and I could now measure the weight of drops of water in micrograms, 1/1,000,000th of a gram. Now, when on the topic of micro, I should point out a couple of quick things. For starters, that's a microgram. You notice how that's not a letter that you're used to? That's a mu. The symbol for micro in the SI system is the Greek letter mu, lowercase. This, of course, is not actually on keyboards, so to type this, you would go into your word processor of choice, find the symbol function, and then insert it. All modern word processors have it. It's a Unicode text. It's pretty straightforward. Handwriting, fairly, just make a U with a tail in the front. The medical community ran into a bit of a problem with it because doctors are legendarily known for bad handwriting, and it turns out a sloppily written mu turns into an M if you're like really bad at handwriting. So in the United States, instead of writing mu, the medical community writes an MC. In the United Kingdom, they just do not abbreviate microgram at all, and they write out the entire word microgram. And in the science and engineering community, we just type the thing because why are we handwriting this stuff? This doesn't make sense. But anyways, so yeah, that's the mu. A couple caveats. While we're on the topic of caveats on units, you will still occasionally see the cc used. This is the same as a milliliter, or 1,000th of a liter. It dates to a previous attempt to reform the metric system from the 1950s. Yeah, basically that's an obsolete unit. No one is supposed to really be using it, although it's one of those things is once something gets started, it never dies. And the CC, once again, it's an obsolete unit. The medical community really would like it to go away because a sloppily written CC looks like a double O, so you can accidentally make something look like it's 100 times bigger. Yeah, handwriting. Anyways. So yeah, there's a brief intro into your SI system units. We'll call them metric units. It really is very much derived from the metric system, but the metric system has not been used in a long time. It is now the SI system. So with that said, have a wonderful day.